Assalamualaikum warahmatullahi wabarakatuh. Shalom, Om Swastiastu, Namo Buddhaya, greetings of virtue.
Good morning, ladies and gentlemen, and welcome to the
Second
second
day
day
of
of
CENIM
CENIM
2025.
2025. Alright, we are so pleased to have you here again on the day 2 of CENIM 2025, whether you're joining us on Zoom or in the main conference hall today.
Absolutely. But before we start today's session, let us introduce ourselves. I'm Natasha, and I'm here with my partner Darren as the master of ceremony for today's conference.
We are very excited to guide you through this enriching day full of insightful sessions and discussions, where
On today's agendas, we will have two keynote speakers, which the first keynote speakers will brought up by Professor Hong from National Sun Yat-sen University, Taiwan, and the second keynote speaker will be brought up by Associate Professor Dr. Surya Sumpeno.
then we'll continue on to our first parallel session, and then followed up by a lunch break from 12 p.m. to 1 p.m. And then we will have our second parallel session, where we will close off our day by having a closing ceremony, where we will present the Best Paper Award. And we hope that all of you will stay till the closing ceremony, because who knows, maybe your paper is the best paper for today.
That's right. All right, before we start the event, let's start our time to take a pray due to our beliefs. Pray begin. Amen. Without further ado, let's move to our first keynote speaker, which joining us on Zoom meetings, Professor Horn from National Sun Yat-sen University. And we also like to invite Mr. Muhammad Adib Shamlan as the moderator for this session. Please give a warm welcome to Mr. Adib.
Okay. Good morning, everyone. My name is Muhammad Adib Shamlan. I will serve as the moderator of this current session. So the third keynote speaker for CENIM 2025 is Professor Jason Horn. So he will talk about the recent advance in human-centric integrated sensing and communication technologies achieved through MIMO-based 4D radar sensing. First, I will treat the curriculum vitae of Professor Jason Horn. He received his PhD from the University of California, Los Angeles in 1992, and is currently a chair professor in the Department of Electrical Engineering at National Sun Yat-sen University, Taiwan. He has authored 2 books, published more than 300 technical papers, and hold over 80 patents worldwide. His research focused on radio frequency system in package technologies for wireless communication and Doppler radar sensing. He has received numerous honors in Taiwan, including National Science and Technology Council Outstanding Research Awards in 2015 until 2020, the NSTC Future Technology Awards in 2020, the Pan Wen Yuan Foundation Outstanding Research Award in 2023. He also a dedicated contributor to the IEEE Microwave Theory and Technology Society, MTTS, for more than 3 decades. He also founded the IEEE MTTS Tainan chapter and was elevated to IEEE Fellow in 2016. Okay, I would like to invite Professor Horn to deliver the presentation virtually. The time is yours.
All right, thank you, Chairman, for the kind introduction. So can you hear my voice?
Yes.
Okay, very good. So let me play my slides. So can you see my slides?
Yes, we can.
All right,
See.
so I will begin my presentations. Good morning, everyone. My name is Jason Hong.
It's not yet slideshow.
Oh, the slide is not. So I share my slides. Can you see my slides yet?
Not yet.
Not yet. Maybe I. All right. Maybe I will share my slide again. Let me.
I think you need to share
Oh,
the slideshow
all right.
instead of the presentation.
Maybe. Sorry. Please wait a minute. I will open my slides, and I will share my slides. Maybe I use the. So do you see my slide yet? Not yet.
Yeah, we can see the slides, but not in slideshow. I think you need to share the slideshow instead of the
All right.
presentation.
How about this? I show the slide in the full screen mode. Can you see my slides?
Yes.
All right. So can I begin my presentation?
Yes.
All right. So good morning, everyone. My name is Jason Hong from the Department of National Sun Yat-sen University, Kaohsiung, Taiwan. My research focuses on eye-front antennae for communication and radar systems. Today, it's my great pleasure to share with you our recent research work on enabling human-centric integrated sensing and communication ISAC systems for ubiquitous healthcare applications. This is the outline of my presentations. First, I will introduce the opportunity and the challenge of ISAC based on the progress of the global standardization in 6G systems. Next, I will describe the fundamental technology for sensing, which combine radar, MIMO, and channel state information (CSI). Then I will present three more static ISAC systems using four-dimensional radar technology, including a base station CSI-based monostatic ISAC system, a repeater-assisted passive sensing system, and a spectrum-connected active sensing system. And finally, I will conclude with a brief summary. Our ISAC research was motivated by the SECG white paper on localization and sensing published by the University of Oulu in Finland 2020. And this white paper reports that ISAC aim to create environmentally aware communication systems and enable new localization and sensing service in future 6G networks. The white paper also highlights key technology for sensing, including active and passive sensing, radar, beamforming processing, intelligent reflective service, and AI. And these are the core technology of our sensing research for ISAC applications. In the following, I will discuss the ISAC standardization progress in 3GPP, the global telecommunication standard body. This figure shows the well-recognized field diagram for International Mobile Telecommunication 2030s, provided by the International Telecommunication Union (ITU), and this figure presents 6 usage scenarios in 6G system. Among them, immersive communication, basic communication, and hyper-reliable and low latency communication are enhancements of original 5G features. And the integrated sensing and communication ISAC, integrated AI and communication, and the ubiquitous connectivity through non-terrestrial network (NTN) present new features of the 6G systems. And
I'm sorry, Professor.
today's presentations focus on ISAC, which was defined by 3GPP in Release 19 and include 2 main objectives. One
I'm
is the
sorry, Professor,
communication.
but the slides, it's still in slide 1.
Okay,
Oh, right
slides.
now it's,
There's some slide problems.
right now it's in slide 4. Is
All
it
right.
correct?
So basically, can you see my slide?
Yes. Right now
Yes.
it's in slide 4. Is it correct?
In the slide 4, yes, correct.
Okay. Thank you.
So the slide actually is not, because I played the slide in the full screen mode, maybe something wrong in the full screen mode. Maybe I use this, maybe use actually, maybe I just show the slide
Yes, yes.
in this mode, all right? Okay, so I just mentioned that this field diagram presents 6 usage scenarios for IMT 2030, which is 6G systems, and there are 6 scenarios, and the immersive communication, the mesh communication, and the hyper-reliable and the low-latency communication are the enhancement of the original 5G features. And the new feature includes the integrated sensing and communication ISAC, and the integrated AI and communication, and the ubiquitous connectivity and through the non-terrestrial network (NTN). And today's presentation focus on ISAC, which was defined by 3GPP in Release 19 and include 2 main objectives. One is the communication assisted sensing, and the other is sensing assisted communication. And in short, sensing and communication will mutually benefit each other. In Release 19, 3GP proposed 32 use cases for ISAC sensing applications. First is the object detection and tracking, such as sensing animals and humans and automobiles and automatic guided vehicle (AGV) and unmanned aerial vehicle (UAV), etc. Second is environmental monitoring, such as detecting rains and the rainfall and floods. And the third is the motion monitoring, such as recognizing human activities and gestures. Among these 32 use cases, there are many related to human sensing, including intruder detection, collision avoidance, human counting, health monitoring, sports monitoring, activity recognition, and gesture recognition. Human sensing is also a primary focus of our ISAC research, where we follow the 3GPP evaluation parameters such as sensing, transmitter and receiver properties, sensing targets mobility and the distribution, and the minimum distance between transmitter and receiver and between sensing targets to set up the sensing scenarios. 3GPP also proposed key performance indicators (KPI) or specifications for all 32 use cases, including competence level, positioning accuracy, velocity accuracy, sensing resolution, sensing latency, reflection rate, and the mission detection ratio, and also phone alarm ratio, etc. As shown in this table, compared to object detection and tracking and the environmental monitoring, motion monitoring demands the most strict KPI, including a positioning error of less than 0.2 meter and estimation of the velocity error less than 0.1 meter per second, and the range resolution of less than 0.375 meter, and the velocity resolution less than zero point 0.3 meter per second, which serve as the target specification for our ISAC research. 3GPP also highlight two sensing configurations. The first is the more steady sensing configurations, where the sensing transmitter and receiver are collocated at the same place. The second is a bistatic sensing configurations, where the transmitter and the receiver are at separate locations. In practice, the more static configuration is more widely used, mainly because determining the position of objects is simpler. In this case, the object's position reference to a single point, the co-located sensing transmitter and receiver. However, in the bistatic case, the object's position must be referenced to separate points, the separate transmitter and the receiver, which makes the positioning algorithm more complex. Just like 6G is developing ISAC next generation Wi-Fi systems are also standardizing sensing under IEEE. And use transmitted signal from external sources such as the television and the radio broadcast station or communication base stations. Patch data can operate in either more static or bistatic sensing mode. An ISAC system can provide both communication and sensing at the same time, so we need to consider the coverage of each function. Communication coverage is estimated using Friis formula, where receive power decreases with the square of the distance. For sensing in more static sensing mode, the radar equation is used, and the receive power decreases with the fourth power of the distance. As a result, the sensing range is typically much smaller than the communication range. For example, if the communication range is 100 meters, the sensing range is approximately the square root of 100, which equals 10 meters. Therefore, ISAC systems require repeaters to extend both communication and sensing coverage. These repeaters receive signals from base stations, amplify them, and retransmit them to user terminal (UE) in out-of-coverage or non-outside regions. The sensing capability of the repeater is realized through an inject lock oscillator IO-based recognitive radar technology. In our research, both the base station and the repeater employ more steady sensing configurations. Communication signals have a limited bandwidth, usually about 100, 200, or 400 MHz in the current 5G or future 6G systems, which restricts range resolution and lead to lower sensing quality. To address this problem, we use a connected sensing mechanism that allows the radar in repeater to operate in three modes: passive sensing, spectral sensing, and active sensing. First, the radar works in a passive mode using existing communication signals such as Wi-Fi and 5G signals in the environment to detect the presence of the targets. Then it switches to spectral sensing more to search for channels not occupied by communication, which can be used for sensing. Finally, it moved to active sensing mode, transmitting dedicated radar waveform on this available channel. Compared with passive sensing, active sensing offers higher signal-to-noise ratio and wider bandwidth, significantly improving sensing sensitivity and resolution, and ultimately leading to much better sensing quality. Our group developed an original injection lock radar architecture that achieves much higher sensor sensitivity than conventional radars such as continuous wave and pulse radars. The key idea is to inject the, the target signal into the oscillator. By observing how the oscillator output change, we can extract meaningful sensing information depending on what property of the oscillator output we measure. The system can support multiple sensing modes. By detecting the phase variation, we achieve passive sensing under injection locking. By detecting the frequency shift, we perform active sensing under self-injection locking. And by detecting the amplitude change under injection locking, we enable spectral sensing, making this architecture very suitable for connected sensing application. The main reason for the superior sensitivity of this architecture is that injection locking strongly suppresses the oscillator phase noise, and its inherently narrow locking bandwidth effectively filters out channel noise, and these two effects significantly improve the signal-to-noise ratio, resulting in much higher radar sensing sensitivity. Human sensing with radar begins with one-dimensional microdoppler, which capture motion pattern and vital sign frequencies such as respiration and heartbeat. As the more spatial dimension are added, the radar gains more information for motion detections. For example, two-dimensional sensing provides range Doppler information to distinguish the distance and the velocity of different body parts. Three-dimensional sensing and provides planar imaging, allowing the system to locate the chest region to extract Doppler signature for accurate respiration and heartbeat measurements. And the four-dimensional sensing delivers a three-dimensional image combined with Doppler data, including target range, elements and elevation, and Doppler velocity, and this rich information enable more reliable posture recognition and precise vital sign extractions. This slide shows how our four-dimensional sensing system extracts Doppler phase shifts from the chest region to measure vital signs in a stationary person. Tiny chest motion from respiration and heartbeat modulate the phase of echo signal, forming the basis of the detection process. For respiration, we filter the Doppler signal in the 0.1 to 0.5 Hertz bands and use autocorrelation and peak detection to obtain respiration rate (RR) and its variability (RRV). And for heartbeat, we apply ensemble empirical mode decomposition (EEMD) to isolate the heartbeat component, filter in the 0.85 to 2 Hz band, and extract heart rate HR and the heart rate variability HRV with autocorrelation and peak detection. And with this procedure, the system can accurately deliver RR, RRV, HR, and HRV, demonstrating that four-dimensional radar can perform reliable and non-contact vital sign monitoring. Another key foundation of our ISAC system is the use of a MIMO architecture. This enables the MIMO communication and the MIMO radar system to share the same base station transmitter for reducing the primary hardware cost, and to share the same signal waveform for saving variable spectrum. In this setup, in addition to the UE, we add a sensing receiver at the base station to enable more steady sensing configurations. The UE performs channel estimation to generate what I call the bistatic channel state information matrix, which is used to decouple multiple spatial data streams. Meanwhile, the sensing receiver also performs channel estimation to estimate and generate what I call the more static channel state information matrix, which is used to construct the four-dimensional images. So in about MIMO ISAC system, the base station transmit antenna are arranged horizontally, while the sensing receive antenna are arranged vertically, forming a two-dimensional vertical array for detecting the elements and elevation of the targets. The spacing between two adjacent antenna elements is set to half a wavelength to avoid the generation of a grating lobe in the array patterns. The more static CSI matrix obtained through channel estimation by the sensing receiver is a four-dimensional matrix consisting of the transmitting antenna dimension, the receive antenna dimension, the Scalia dimension, and the packet index dimension. These four dimensions are used as follows. The horizontal transmitting antenna array estimates the elements of the echo. The receive antenna array estimates the elevation of the echo, and the scalar frequency response is transformed by inverse Fourier transform to obtain the echo delay that can be converted into range information, and the phase variation of the echo over packets provide the Doppler frequency shift that can be converted into velocity information. The sensing resolution of each dimension can be estimated using corresponding formula shown here. Next, I will show you our prototype ISAC system with four-dimensional sensing capability applied to human monitoring. First is a monostatic ISAC system. Use base station transmitter CSI information, which include an 8-channel base station transmitter and an 8-channel UE receiver, forming an 8 transmit and 8 receive MIMO communication mode. Moreover, the same base station transmitter are combined with a 6-channel sensing receiver, forming an 8 transmit and 6 receive MIMO sensing mode. And the photo on the top right shows the base station transmitters, sensing receivers, and the two-dimensional virtual array, which are placed at the front of the experimental scene, as shown in this photo. And in the middle of the scene, you can see there are two targets, two subjects, in the middle of the scene. And in the back of the scene, the UE receiver is in the back, at the back of the scenes. So the experiment was conducted at 7.1 GHz in the FR3 band using 1,644 Scalia 64 quadrature amplitude modulation QAM orthogonal frequency division multiplexing FDM signals with 100 MHz bandwidth. The power per channel was set to max 6 dBm. Now let me play the video. Let me see. Maybe I show the video in the full screen mode. Maybe I can. Can you see my video?
No, Professor, I can see it.
How about this? Can you see my? Can you see video?
No.
Maybe. Okay. Maybe I try this. How about this? Can you see the video?
Yes, we can see.
All right. So you can see the videos. On the left is the output from the UE receiver, showing a throughput about 3.4 gigabit per second, corresponding to a spatial efficiency of the 34 bit per second per hertz. On the right is the output from the sensing receiver, showing real-time three-dimensional image of the two subjects by checking the Doppler frequency shift at the chest region in the image, which can obtain the Doppler velocity for each subject to estimate their vital signs, including respiration and the heart rate. So as a result, the sensing receiver output four-dimensional sensing information as shown in the left figure, including the positions, image, and the vital sign information, and the UV receiver output communication performance information, such as bit error rate and the throughput. Moreover, by combining both sensing and the communication output, we can see from the right figures how the moving subject blocks the communication between the base station and the UE. Specifically, the bit error rate rises sharply when two subjects switch seats. As seen in the video, this blockage is likely to occur because signals in the FR3 band have a weaker diffraction capability compared to those in the FR1 band. And this is another experimental video focused on sports monitoring, one of the 32 use cases proposed by 3GPP for ISAC sensing. So let me play the videos. I'm sorry. Okay, I try to play the videos. So can you see the video? Maybe.
Yes, we can see it.
Okay. So if you can see the video clearly, let me know. So in this video, the subject begin the warm-up exercise in a standing position and perform sit-up exercise alternating between sitting and lying positions. And this system can track the chest regions in the image to extract the Doppler velocity, which is then used to analyze motion and vital signs to evaluate the effect of the exercise. The simultaneous communication maintains high performance with a throughput over 3 gigabit per second. The second demonstration system is a repeater-assisted passive sensing system. The repeater receives signal from base station and retransmit them to the UE, thereby extending communication coverage. In addition, passive radar is integrated into the repeater to enable a more static sensing configuration. The experiment used 2.4 GHz Wi-Fi signal. The communication mode is 44R MIMO, and the sensing mode is 80AR MIMO. The modulation scheme is 64 carrier, 64 QAM OFDM with a 20 MHz bandwidth, and the transmit power is 5 dBm. So let me play the video again. So maybe. Can you see the video clearly?
Yes.
All right. If you can see the video clearly, let me know. So you can see the imaging results of the subject sitting at the left, center, and the right flank of the repeater, either kicking his leg or remaining still. The Doppler frequency shift is extracted from the chest region in the image to generate the spectrograms. I can see the spectrograms. For vital sign analysis, and the analysis showed that the subject respiration and the heartbeat frequency is around 0.25 and 1.5 Hz respectively, and these vital sign frequencies are more easily identified when the subjects remain still. The third demonstration system is a spectrum connected active sensing system. It combines a repeater with an active radar to form a more static configuration, and this radar can scan the spectrum to find available channels, and then transmit its own waveform for sensing. In this setup, we use the ATAR MIMO sensing mode at 6.4 GHz with frequency modulation continuous wave, FNCW modulation, 1 GHz bandwidth, and 1 dBm transmit power. And let me play the video. So, with the larger bandwidth, the range resolution improves, giving human image more depth information. When the subject remains still, it's easy to identify the respiration and the heartbeat frequency for each subject, about 0.25 and 1.3 Hz, respectively for target 1, and about 0.25 and 1.5 Hz for target 2. This slide demonstrates how we achieve non-outside sensing using a liquid crystal LC reconfigurable intelligence service RIST. In this experiment, the subject sits outside the radar line of sight, so the radar cannot capture the microdoppler signal from the subject directly. When the LC RIST is turned off, the vital sign waveform is very weak and noisy, but once the LC RIST is turned on, and it steers the reflected beam toward the subject, and the radar immediately recovers strong and periodical vital sign signal, and this shows that RIST technology can effectively extend ISAC sensing range into non-outside regions. Our future work will explore how AI can enhance ISAC. We are now collaborating with Professor Jiahong Ye at National University on these topics. The idea is to use the transformer-based AI model to extract the key features of human posture and limb motion from morphostatic CSI generated by the sensing receiver, and then build a skeletal model for posture and motion recognition. And we also plan to further combine the camera imagery in the UE with inertial measurement unit IMU data through AI to improve the accuracy of UE-based three-dimensional simultaneously localization and mapping SLAM. Another our future work is to use sensing information to improve communication performance. We are now collaborating with Professor Tao Kai Wen at National Sun Yat-sen University on this topic. The idea is to integrate existing cellular information, such as base station deployment, UE positioning, CSI feedback, and call book, with new information, including target sensing from base station and the SLAMs generated by mobile UE. By fusing this information with AI, we aim to develop context-aware beamforming to overcome the challenge in the FR3 bands for sexual application where weaker diffraction makes communication more easily blocked by people or objects. In summary, I have three concluding remarks. First, ISACs will make wireless sensing as accessible anytime and everywhere as modern communication systems. Second, MIMO-based four-dimensional radar technology will serve as a foundational technology that enable ISAC sensing capabilities. And third, human sensing will be a major ISAC application, particularly for continuous and non-contact healthcare applications. This concludes my presentation. I will be happy to answer questions in the upcoming discussion, and thank you for your attention.
Okay, thank you very much for the wonderful presentation, Professor Jason Horn. Now we'll move to the Q&A session. Maybe for the audience have a question. Okay.
Thank you. Good morning, Professor. Can you hear my voice clearly?
Yes, very clear.
How are you, Professor?
I'm fine. How are you?
I'm fine too. Thank you, Professor. Thank you for the presentations. You did a lot of things recently. I think, yeah. I have two questions actually, Professor. The first question is, you did mention that you are now doing, detecting or visualizing or do the 4D imaging using the BS signals. But in real world scenarios, will the multipath fading will be the problem? That is my first question. And my second question is about the, you did mention about the RIS, reflective intelligence surface. Did you use the passive RIS or the active RIS? If you are using the active RIS, how do you control the RIS? Yes, can the RIS control the angle of the reflection, or the angle of reflection is fixed?
All right.
Yeah, thank
Thank
you.
you, Dr. Rekis, for the very nice questions. So the first question is about the multipath in the four-dimensional radar technology, the effects on the four-dimensional imaging. Yes, the multipath is a key concern, but the effect of the multipath depends on frequency. For maybe millimeter wave frequency, the multipath is actually not so significant. However, for the frequency maybe in the FR1 band sub 6 gigahertz, so the multipath will play a very important role in the radar image and may distort the radar image. So we need to actually calibrate the multipath before we perform the radar sensing. So when we apply the radar to sense the environment, the first step to calibrate the environmental effects and the multi effects need to be calibrated very clearly to ensure the sensing qualities. And for the second question you are asking about risk, basically, as I mentioned, our risk is implemented using the liquid crystal, so it's an active risk. So we can use the voltage to change the direct constants of the liquid crystal. When the direct constant change, the phase will change too, so the beam and angle can change accordingly. So and the reason we want to use a risk crystal because it's low power consumptions. So we can use a liquid crystal to control the angle of beam forming with low power consumption. This is the reason we want to apply the liquid crystal technology in the wrist.
Thank you, Professor, for the answer.
Thank you. Thank you for the questions.
Is there any more question from the audience?
Yes, good morning, Professor.
Good morning.
Yes, this is Norma Hermawan. We have exchanged email several times. Thank you very much, finally, for your presentation today. It's our honor to have you as a keynote speaker in this event. And also thank you very much for your willingness to present your recent research. So maybe my question here is related with your research, but maybe not uh, very precise because I have a little bit different field. But a couple years ago, I also worked in telecommunication company as a programmer. I developed a small program, and as MVP client, I think it's also part of 3GPP protocol. And I think what you have presented today, the radar biosensing technology is also part of roadmap of the sixth generation, fifth generation or sixth generation of telecommunication system in the future. So maybe my question is related with the application of the radar sensing technology. I think could you please maybe explain a little bit about the practical application in future about that biosensing radar technology? Thank you, Professor.
All right. Thank you for the very nice question, and thank you for inviting me to participate in this conference. And actually, it's a very good question because the ISAC actually application is very important. And in 3GPP meeting, actually there are many discussion in the ISAC, particularly in the applications. And in the release 19, there are basically they summarize 5 key applications for ISAC systems, and these 5 key applications are listed as the study item in release 20, and maybe soon will become the standard of the 6G. And in my memory, these 5 key applications include human sensing, and the sensing for automobiles, and also the sensing for UAV, unmanned area vehicles, and also the sensing for HEV, and also the sensing for maybe the dangerous objects. So these 5 key applications, sensing applications, are now become the study items in release 20. So when you want to study the ISAC systems, particularly you want to focus on the application, and you can follow the discussion in the release 19 and the 20 of 3GPP, and I mentioned these 5 major applications: humans, automobiles, UAV, HEV, and dangerous objects can be our focus in the applications. So can I answer your questions?
Yes, I think that's
Okay,
answer the question. Thank you very much, Professor.
thank you.
Any other question?
Thank you. Good morning, Professor
Good
Jason.
morning.
I was very pleased with your insightful presentation. And I'd like to ask one question about what are the inherent limitation or potential shortcoming or potential challenge in the next future about your proposed multimodal sensing framework. Thank you.
All right. This is a very good question because if we want to deploy ISAC, then you have to maybe have some motivation for the operators, for current operators in the mobile communication. They have to invest the the future 6G maybe base station, which can predict the sensing capability. So I think the the limitation is the hardware because you have to add the hardware cost to the existing mobile systems such as the 5G systems. For example, the current system actually didn't have the function of sensing. So if we want to use the base station or the UE to have the sensing function, you may increase the hardware cost by adding some hardware components such as the sensing receivers. So the limitation is the hardware, and the operator had to invest the hardware. But the motivation for them to invest is they can have a business model to provide communication service and also sensing service at the same time with the same spectrum. So they can benefit from the ASAC systems. So we try to persuade the operators this actually this investment is worth because the sensing, particularly for humans, for health monitoring, is very useful and very popular in our features. Have I answered your questions?
Yes, Professor. Thank you very much.
Okay, maybe last question. Okay.
Okay, hello Professor.
Hello.
For the introduction, my name is Octavian Alianza. I want to ask about what if the obstacle in front of the target if the radar will work like as we should. Thank you.
So can you repeat your question again? So you want to ask the property of the targets?
Yes.
Okay. So our main sensing target is humans. So you can see our four-dimensional memory radar technology can detect the human, including their positions, their image, and their vital sign. So the human actually can be mobile. They can move everywhere, and the system can track their positions and also their postures and also their vital sign anytime, anywhere, using the existing communication signals, such as Wi-Fi or future 6G signals.
Okay, thank you for the answer, sir.
Thank you.
Okay, because the time is already up, maybe that's it for the Q&A session. Thank you very much, Professor Hong, for delivering their presentation. Please give one more applause for...
Thank you.
Okay, I will give it to...
All right, thank you, Mr. Adib and Professor Hong, for the insightful session. And now, maybe we will have a symbolic appreciation for the committee. Please be prepared. And for Mr. Norma, please welcome to the stage.
And maybe we would like to ask Professor Jason Hong to turn on the camera because we will have a documentary session together with the appreciation plaque.
Yes, sorry, Prof. Hong, this certificate is our token of appreciation for your participation as keynote speaker, and we would like to express our deep gratitude for your participation. Thank you very much, Professor.
Thank you, Dr. Hermawa. Thank you very much.
And also, it's a little bit symbolic gift. We will send it by post to Taiwan. Maybe you can put it in your room to remember our collaboration today. Yeah. Thank you, Professor. Yes, thank you very much. I
Thank
give
you.
it to the moderator.
All right. Once again, thank you for Professor Jason Hong for bringing us a insightful session for today, and especially because you're all the way from Taiwan, giving us a lecture from us at Surabaya. It means a lot to us. So thank you again, once again, Professor Jason Hong.
All right,
Thank you, everyone. Thank you.
all right. Maybe if you have any closing statements. Oh, it's okay. Okay, for the audience, we will have a short break until 9:30. So if you want to take a drink or maybe some snacks, you can go to the back of the hall in the left side or right side. Okay.
Yes, but please be sure to be back here by 9:30. Thank you, everyone. Please have your break.
at least in the past we have a picture, very traditional. One is the picture, and usually we also video, and the past will the maybe 10 or 5 years ago using low resolution. We call it now low resolution video. But now we have already have in regular daily activities we use FHD resolution or 2K maybe. In the future maybe we'll have 4K or 8K resolution with high quality of audio. The topic, the big topic of the CENIM conference is high impact innovation in computational intelligence and biomedical engineering for sustainable healthcare and smart society. So I emphasize the word high impact innovation and computational intelligence and also smart society. I forgot to mention, thank you for the team for the CENIM, especially Professor Norma and Professor Zaini, who happen to be working team or committee for this conference. Where's the next one? Oh, okay. Who am I is already given partially from the Professor Fuad. I'm going to historical, a bit nostalgic about my past research in Tokyo University. Why I'm telling you this? Because I want to emphasize to you, to show you that how rapid the AI now begin, how rapid the AI begin. And after this, after my nostalgic experience, I will show that AI now is everywhere, everywhere. Recently, Microsoft requires some laptops to be Copilot certified. Copilot is AI at your hand, in your desktop, in your laptop. AI, it's not far away, but your daily companion. Also, Samsung using the AI for the marketing gimmick for their products. And I will show you, this is the display of, should I call it, AI machine for Pursman, Pursman AI machine. We can utilize our existing mini PC or PC to equip with the AI and use it as your daily activities. It's also demonstrate that AI is not pricey. You can afford it. Only add some components. Especially here now, I am using NVIDIA GeForce class or RTX. RTX. It's a bit old, 2060 series Super. I bought it about some years ago, but I'm currently using it as AI. Oh, this is my master degree, magister study research, a video object extracting system and performance analysis. It is using semi-supervised machine learning approach. Although it's not explicitly stated in the title. It is conducted in about 2006. 20 years from now, very long time ago. What I do, what I did is we want to. This title is a bit blurred. To extract video object from interest from a series of consecutive video frames. For example, this we have a Foreman video right there. You can play it. How can play? I cannot play it. Press the play button. Oh, okay. Oh, I see. Oh, I see. I forgot to copy the video. Okay. I mean, there's the right side. We have a full video of foreman here, and we want to extract only the foreman and remove the background. Yes, it is currently. Is it easy task right now? Yes, it is right now. Very easy task for you to do that. But 20 years ago, it's very hard to do. We have to use many effort to, technically speaking, not the user perspective view. Also, for example, another example is our horse riding woman here, coming from the jungle or the woods, and we want to mix that with the background of the wind turbine in maybe in Netherlands. Now you using CAPTCHA or CapCut, you can use very easy, but please in 2000 very hard to do. Okay, we in machine learning we have to utilize feature extraction, spatial, color, motion, texture, and age, because they will be used in the machine learning approach to extract video of interest, object of interest of video. Okay, I'm skipping. We use it is called learning vector quantization. Actually, we did that with Professor Haryadi. Professor Haryadi is currently here. Semi approach mean that we as a user must provide the initial frame, human assistant, and initial frame, provide a guideline for the machine to, here is the object, initial object that we want to extract. And then the machine will do the rest by using object tracking, using learning vector quantization and image segmentation until the rest of the video. This is called semi-automatic approach. This is manual and the rest is automatic. So it is semi-automatic. Skip, we use foreigner region, and we have 5D dimension vector quantization. Skip. What is LVQ? I don't believe it's interest to you. Object tracking, we have the answer, and we can use the LVQ, vector quantization, using colors. And then we have vector, codebook vector. It's called codebook vector. It's actually some kind of centroid. The darker one is a centroid for the object. The red one is not the object, or we call it background maybe, not the object. Codebook vector, we're using pixel labeling. This is the simplification of codebook vector. Actually, it's much smaller. So we have a bit precise pixel by pixel extraction, some kind of that. object tracking, and then also, okay. Previous research, we have a rectangular shape region of interest, but I'm proposing we use some kind of masking automatically from the object. So what I do, it's so not that we can be reduce the time computation, and surprisingly also the increase the quality of the extraction. Reduce the number of code vectors, and we have now there. This is the result of we have four sample of video object, Claire, foreman, horse riding, and table tennis. There was a standard video object for maybe before the MP4 era. Some of them. We did not proceed the whole sequence, but we sample that represent some characteristic of the video movement. Claire is bit easy, Claire, the sequence here, because it's only anchor to do the video TV broadcast. Not many movement. For men, on the other hand, a little bit complex. And horse riding is very complex because it starts with a small object, and she riding closer to the camera, and eventually the horse disappear total. So this is a challenge for at the time. And the last one is table tennis. Is fixed camera, but the player move very, very fast. So you have to catch the track into object. This is the sequence, frame by frame. Actually, the video, as you know, that video is consecutive image. So we extract the video into the image, and the image we proceed one by one and compose it again into the video frames. This one is playable. The next is only the video sequence. The result is in the next sequence. Look at this error. It's boring. We have error extraction, missing object, or added background. In the confusion metric, we can also rate this as a false positive and false negative. This is the result. Okay. A video, please play. This is the result. Previous algorithm proposed almost the same, because the previous algorithm did very well. We did also very well, but the computation time is almost half from the 5 seconds per frame into the 2.76 per second, using the highest machine at the time, highest premium machine, not the highest. This foreman, a little bit error. I mean the accuracy higher than the previous algorithm, and the computation is cut in half. Horse riding, proposed algorithm perform well beyond the previous, and the computation time is shorter, etc. It is very interesting. Previous algorithm, the error is visualized by red dot in the left side of the slide. And the proposed algorithm, the error is in the dark dots. You can see that the error is much, much lower. I was very proud, very delighted. It's my ticket key to graduate as magister student. That was the time. But how about today? How about today? You can extract the video using this prompt. Extract the face of the man and has remove the background and voila, you can extract it. Very simple instruction. And the beauty of this is it is open source, and this machine is general purpose. Using the simple workflow, you can edit anything. The Confine UI use a template, one of the standard template, and it's called image editing. Image editing, it means that you can edit anything from the reference image into anything you like with the prompt of the text. It is way beyond my capability. I did only object extraction, but this workflow do anything. We will show it. This the the previous example. The prompt: extract the horse riding woman and the horse remove the dragon. Voila, and it's very accurate. And we do it by only comment the system, not assisting them. And it's like previous research, we use masking. You know, the masking is something like magic wand is in the Photoshop. You have to erase the background pixel by pixel if you want to. If you want the video extraction go smoothly until the end, you have to provide exact mass reference. But now you don't have to do anything, just comment the AI, remove, voila. You can also do this thing because you can do installing it in your desktop, in your laptop. Laptop maybe have a performance laptop. I'm doing it just a few days ago using RTX 5060 VRAM 16 gigabyte from NVIDIA. It takes about 200 seconds. It is previously we used the foreman in the initial. It takes longer because the model need to be uploaded, and you have just shake your head. Oh, it's done. Very fast, and we use it with what's that called? Medium range of desktop. If you have a higher premium, you can do it. We can do it faster. The system will do it faster. Okay. Is AI for everyone? Certainly. So, artificial intelligence consists of what kind of right now, currently, AI is umbrella of many things. Currently, the popular one is deep learning. Deep learning, DL. Previously, we use terminology like machine learning. Machine learning. Now we have natural language processing. Previously, using semantic, etc., etc. Now using LLM or SLM, small language processing, and Professor Watt already done many experience, any research using LLM. And of course, computer vision, AI that enables computer to recognize and interpret image and video, expert system, robotics, fuzzy logic, and reinforcement learning. That is, the last one is very powerful also. This is the largest companies AI by market capitalization. Currently, we do have two groups. Groups is a kind of political AI. I think the one is a US US group. The other one is Chinese group. China. There is now ongoing war, semiconductor war in the state of the art of the AI AI world. But here it is: Microsoft, Nvidia, Apple, Alphabet. Because this is suggested by Western media, only list the Western company. The other one is Alibaba and Baidu. It is not, I don't know, maybe considered illegal or quote unquote not recognized by. But we have Huawei here. Also about some Huawei too. I wonder what kind of Huawei provide us for the AI also. Huawei here, and then the other one is Western. Nvidia, Huawei also, Alibaba, chip makers. I don't know. I suspect that China already have maybe it's, but operated kind of in the military or secret, that they have surpassed the capability of US counterpart. Just rumors. 5 mobile AI chips, Apple, Huawei, MediaTek, Qualcomm, and Samsung. Huawei is Kirin, using Kirin. The other one maybe you are familiar. Perhaps you have, I certainly assume or suspect that you have at either MediaTek or Qualcomm, or you have a Samsung also. 5/8 AI chips. So AI, currently you have the option to using AI as a service from the cloud using Gemini Pro. If you are a student, you can, it's already passed. You have opportunity to have a Gemini Pro license, but it is run on the servers on the server side, cloud, away from your smartphone. But if using it, you can do it locally near you. It's Nvidia, the popular one is Nvidia. We use also Nvidia Jetson Nano Orin, Nvidia, what's it called? Pandora. I don't know Pandora. I haven't had the opportunity to crack it yet. Another one is Google HTPU. It's not very popular here. And other one, I only know the. How about Indonesia? Indonesia bought some from Nvidia, DGX A100, including ITS. Gunadarma have more than we have. Gunadarma, very powerful. ITB, UI, UGM, Dianuswantoro, Universitas Jember, DGX, we have also the opportunity to explore the possibility using AI, utilize the DGX. This DGX, what cost now? I don't know. How much? What? DGX, one million rupiah. Tops. Forget. But right now maybe 100 million rupiahs. Yeah. Very expensive. But if you buy first time, it will become the second hand. It's the price will be drop very fast. Okay. And the user, you or how many audience you have a Copilot laptop? Copilot laptop. This one is Copilot laptop. I'm showing off my Copilot laptop, and this is what the one with the ARM processor ARM. It is said that if you do the AI test, it will work in the local machine, but I do not believe that. Locally, fully locally, are you kidding me? I don't know. Maybe partially, right, Pak Fuad? Partially. But if you have, you don't have a Copilot laptop, it will do it not not locally. Almost this function as a dumb terminal, also just a display, but it will run entirely on a server side, I think. So we have many things we can do it in a Copilot. Recall, raise style image, leave caption, click to do anything. So I developed also this slide using the assistant of the Copilot. Copilot, the back end is Smart GPT, I think. Smart GPT. I don't know what is different with GPT-5 and Smart GPT. It's a marketing gimmick. I don't know. Yeah, perhaps. Okay, what we want to do now? Back to our current state. Why Japanese wedding? We have cultural richness and religious integration. The majority of the Java citizen is Islam, Muslim. So they combine the religious activity, religious sacred ceremony with tradition. And usually, as I mentioned, the opening that we documented for lifetime. Lifetime. So it is a very precious documentation. For example, we will show them to our grandchildren. So the grandchildren, what kind of documentation is that? Very ugly. Poor resolution, because our grandchildren will enjoy 8K, 4K, or now we witness, we watched the documentation from our grandparents. It is in a black and white, and also covered scratch, or there's no video. There's no video. But using AI, we can do many more things regarding the previous memory. So I will show you. It is also creative industrial potential. So if one of the wedding organizer, currently it is a very, very popular, very traditional, very common for the people hold the wedding ceremony, use the WO, wedding organizer. Then the wedding organization such as they're kind of professional for organizing. They will do the pre-production and of course the production and post-production. Using AI, they will have this, of course, very great advantages because they will give you, for example, if you want to marry next week, you can contact the wedding organizer and said, I want to pre-wed like princess and in the palace like, or maybe you like the kind of a natural thing. I want to do it in the woods, also like very romantic with a candle dinner also. Anything is possible now. The wedding organizer will provide you the simulation that will happen before uh, the event take place. Simulation to give you the pre, pre preview of the you will be will attend the ceremony and do the ceremony. And during the event, also the wedding organizer will record you, document it, anything with still image, with video, of course. But in the post production, they will upgrade your image, upgrade your video into the more beautiful, more appropriate. For example, if you're not you during the wedding, maybe the smile is already because you are too tired for attending the long hours of wedding. But in the post production, voila, your smile is on your face very brightly. The video also portrays you as a happy couple with perfect anything is possible. And you and the audience, your whole family, perhaps can accept that as a true documentation of the wedding because they certainly don't pay any details regarding the, oh, this is very good of you being there very, very brightly, very positively, and bring happiness to all of your family, to your children in the future, to your grandchildren in the future, because oh, my grandparents are very happy at the wedding, and it will last forever until uh, technically, okay, it's technically glitch. It's in the matrix. Run of battery. Oh, its time is up. Aduh. Why don't anyone try to warn me? Belum ya, belum. Not yet. Not yet. Not yet. Not yet. Not yet. Time is yours. No, not, the time is not yours. Time is ours. So, okay, this is the boring stuff. The architecture of our development. Oh, the one in the bottom is so you can it cannot be read. Very poor text. Okay, yeah, here I will go forward and show you the. It's not working. Okay. It is disconnected, I think. Disconnected. Okay. Generative AI. Generative AI. Now it's called Gen AI for short. Yeah. Gen AI synthesis result as pose reference. If I'm standing here, it's a pose. I'm greeting the audience, it's a pose. I'm handshake with, it's a pose. You can alter the pose after the fact. Yeah, using AI. And people will assume that it's a true because they never see it before, and the couple or the family saw the video and this the documentation, but it's altered state, but it's considered as true. So so that's why we call it now a deep fake. Deep fake considered as fake, or deep fake considered as true. So this is a post-truth era, right? It's in the term of positivity, we tend to regard it as true. Okay, for example, the wedding organizer can provide you the virtual reality simulation before the wedding, in the future maybe. Perhaps you are interested in establishing a wedding organizer using virtual reality setup. You can contact us. No, I'm not kidding. I'm just kidding. Because in the virtual reality, the bride, the future bride, can view him, her as, oh, I will dress like this, in the situation like this, in the room like this, and very happy before the wedding occurred. This triple happiness before, the during, and the post. Triple happiness. It is also open source platform with a many parameter customization. User and post-production operator. If you don't have any knowledge regarding AI or how to operate, you can ask the operator. The operator is, of course, must be trained first and understand how the AI operates. AI generates draft output, operators refine output, user customize and approve. Oh, it's not like that. It should be like this. And then the operator will refine, and after many iterations, maybe, the final melody album will be delivered to the customer with satisfying result from the perspective of the client. Multimedia wedding, you can place it in your cloud storage with your computer, and you can play it afterwards. It is very precious moments, I think. Historical precious. For example, if we don't want anything to happen, right? But your loving ones will depart before before you, then we'll have certain memories to keep in your heart. The multimedia will be very, very useful for it. This is our experiment using many things. The one thing that generative AI is, it can be very wild. You have to tame it. Very wild. It can lose control. Go anywhere that you, beyond your imagination. In your Gen Z term, we call it halu, hallucination. AI can halu beyond our image. What kind of that? I never think of that, but AI can do that. So have to control it very, but it is very tight control. It is not generative, right? It have to lose some control, but in certain area it has to do the control very, very tight. It's like controlling the wild horse, maybe, perhaps. you want the horse to run to the right direction, to behave, not to go widely, and not to go to the direction you want. Continue the organization. This is what.
Wabarakatuh, bertemu kembali dengan saya pada video pembelajaran Studio TV 1. Seperti janji saya sebelumnya, pada video selanjutnya, yaitu video ini, saya akan menjelaskan terkait pengoperasian switcher. Nah, pada kesempatan kali ini, pengoperasian switcher ini saya membawa yang namanya lembar kerja. Pada pembelajaran offline atau tatap muka workshop biasa.
Okay, play. Replaced by Tasha. And give the lecture. Tasha will give the lecture. The references. The top one, Tasha. It's funny, right? So it is deep fake. You can have the Jokowi or oh, not Jokowi. Maybe the other one. Okay. I don't know. Jokowi wearing jilbab? Oh, not a chance. Okay. The one that I use this Comfy UI. I personally I'm using it currently. Comfy is open source. You can install it. Okay. Simple workflow. No Photoshop skills. No Photoshop skills. Just prompt. And no programming. No programming at all. How do the pipeline use the workflow? You simply kind of like us using a visual diagram, connect one node to another node. No programming necessary. Of course, you can do the programming if you want to, but the programming is not required, mandatory, not required. Optionally, of course, you can do the programming. This is the experiment. Start with sketch. What's it? Balloon, yellow balloon is wrong prompt. What the yellow balloon to do with the bright? But you can also add balloon party. But for religious context, okay, the background is the mosque. Oh, very religious. But you can also change the background. Very beautiful lady. From the sketch, I don't know who are there. Probably does not exist in the real world. Probably. The right one, produce the full body, but the sketch is only upper part. So, yeah, you can do anything with the AI. This is the documentation. Using the same workflow, just prompt, create high professional photography from this old picture and voila. No Photoshop required. Very beautiful, right? If you have a old photo album from your grandparents or for your mother, you can restore it. And you can restore to 4K, 8K, higher resolution. Of course, not only Japanese. You can do to old photo, any old photo. Maybe your question was, is it the correct representation of the past? What is the answer? My answer is, I don't know. Is it the red flower? Is she holding? Or yellow? I don't know. We don't know. Suddenly the person there, I don't know, they no longer live here anymore. We don't know. But it is very beautiful picture. And if you see it at the first time, we tend to regard it as the true picture. This one. Documentation. What? what MC? What MC doing there? That. But it's already recorded. It's already captured in the photograph. You can remove it later. Remove the hand with the mic. Voila! Replace the banana with watermelon. Yeah, voila. The other question is ethics, right? Now the ethic. Okay. The start. It starts with the top frame. It is a video. Can please play the left one? Yeah, play. Beautiful. But it's wrong. You can relive the picture of your past, maybe. Maybe Pak Zaini have the memorable picture. I can make it live. Okay. You know okay. It's from the start from the left one. It's also the video. There's the one iteration only. You can see the error there. But it's more beautiful. Okay, I like it. Okay. Next. This is my late father. It's the memory of my late father. He smiled. Smiled to me. I don't know whether my father smiled like that because I was very little one when he left me, died young. So I can assume that is the smile of my late father. I don't know. Okay. AI is affordable for everyone to enjoy, to take advantage. You can do anything. You can do by using open source platform. Open source is free for you to explore, or proprietary if you subscribe to service provided by Gemini, by anyone in the internet to provide you service that provide you with a simple instruction or simple touch and go. It's okay, but not easy too, because you notice some errors. Actually, in Japanese, for example, this is not this one. This is the wrong one. What is the, I don't know, it's made of? You think? It's from metal, from the picture? You see, it's from some kind of metallic. Because in real life, it's from organic material. So it is wrong. Also, the makeup, the pies, Japanese terminology, it's wrong because I don't know, it is from the hair of her hair. But pies is not from the hair. It is wrong representation. But at first glance we can, oh, it's beautiful, but it's wrong. Yeah, right. So in many contexts, it is wrong representation for the eye, for the eye of the expert. Okay, it is also okay. Oh no. So Can Jenny I imagine it one set, although they look beautiful and we can regard it as maybe the true one. That's all for my presentation. I hope this not bored you very much. Thank you.
Yeah. Okay, thank you very much, Professor Surya, for the very open eye presentation for us. So AI is everywhere now, and I think some of you maybe already use it for a daily base or maybe for something more specific. So we go to the Q&A session. Is there any question from audience? Okay.
Thank you. My name is Dimas Rahardika. I'm from Informatic Engineering, student from Trunojoyo Madura. My question is, what is your motivation to do this research? And it is related with your goal that it should have a big impact for our society. And my last question is, how big do you think this technology will grow in the future? Thank you.
Okay, thank you.
Thank you very much. Very good question. First, what motivate me? And actually, my research tend to move in certain areas. Some before this research, I will also we're working with cultural preservation with the Museum Putan Tular, also using virtual reality, and many of my research relate with cultural tradition. So it is also my interest. And I believe in the future, one, each of individual must retain attached to traditional value, because it will matters if you go global, but you have the root from your past, from your mother, from your father. It is very important that you hold, not very much, but it is important for your identity. I am Indonesian. I am Japanese. Lives in the current and future, approaching, facing the globalization, global challenge. I will interact with all of the people, but maintaining my identity, where I come from. It is very, very, very important, I think, because if not, you will lose yourself in the global global scope, in the global village or whatever. So it is an attempt using AI for the restore your memory, restore your identity, strengthen your identity related with our roots. It can be used for any Sundanese or Padang. It can be used. Japanese is just a study case. I will take as an example that it can be used to strengthen, to restore, to relate to conservation or anything. Okay, I hope this. The second one is how I think the future. I think the future AI will embed it further into our ecosystem, our system. I'm wearing glass now, right glass now. In the future, the glass will be intelligent glass. I'm wearing smartphone, a smartwatch. I'm sorry, your smartwatch now is very intelligent. If I walk uh, for about 1 minute or 3 minutes, it will record automatically. As you are walking, 10 minutes from now, you are exercising. What kind of exercising? I don't. But it can be regarded as exercise. If you sit too long, you will be warned. It is good for your health. Another example maybe arise in the future. It happens now is autonomic vehicle, driverless car, robotic, many things. It will in the future our grandchildren will regard it as take for granted. It is already there. Dad, it's already there. Grandpa, when did you notice? Oh, I'm old. In the future, it will embed into your everyday life. There is a small boundary or no boundaries, maybe perhaps. Cyber arms, it is already possible. If you have, if any of one in the other area, with disability, it can be replaced by prosthetic, robotic. So we can see that many big companies move to the AI, move to AI. Google, Microsoft, Nvidia, many players. Okay, thank you.
Thank you, sir.
Okay, thank you. Is there any other question? No?
Okay.
Okay.
Good.
From
Oh,
online, we take
another
question from
one
online.
question. One question.
Oh, one question.
From the
Okay. Sorry.
audience.
Yeah, I'm Jarso. Originally, I'm from Ethiopia, but currently studying masters in ITS.
Okay.
I have one question. Yeah, AI is everywhere, affordable everywhere. Many tasks can be solved in simple way by AI. But my question is that wouldn't this result in bad dependency? For example, now there are images were restored, edited by AI. For example, previously this needs some technical to edit the images. But now this is simply can be solved by AI. Are we not losing our ability maybe in this way if it continued in the future? Wouldn't this result in dependency? Because AI is trained by human being, created by human being. But if we give now all of our tasks to AI in the future, maybe I think it will result in dependency. What do you think here?
Okay, thank you. Very good question also. It is a kind of philosophical question, right? What will we do with the AI currently and the future? There are many examples that full reliance on AI can be a bad things. For example, my generation, my child generation can do the traveling without Google Maps. Now, what can I do without Google Maps? It's very frustrating because everyone, especially younger generation, rely fully on Google Maps. So it is, I think it's bad because if somehow, someday, Google Maps collapse, what will do? What do you do? Can you navigate from here to ITS? This is very nearby, but I cannot do it without Google Maps. Uh, of simple AI is a tool. We have to use it wisely, very, very wisely, and very carefully, because some expert research also warn us that the possibility of the AI in the future. It, if okay, the classical view of the AI as a tool is the same maybe as the view of a knife as a tool. Knife can be used for a positive activity or for a negative activity. You can kill people using knife, but you can also do something very, very useful, very, very beneficial using the same tools. But AI is very powerful, much more powerful than knife. So we have to use. I think the basic education is to somehow we in the grade of education you can do something, prove you can do something without AI, because the full reliance on AI is very, very risky, very, very risky. AI is now held by two two groups, big groups. So if they control it, they will control the world. It is my point of view, and I didn't mean that the AI is very bad thing that you can avoid, because I don't think AI is avoidable. It cannot be avoided completely, because it's everywhere now, and if you are not using it, you will lose the competitive over your competitor, your friend, neighboring nation. And if you can utilize AI to maximize your outcome, your outreach, your performance, then use it, and will beneficial to you. But use it wisely. I think this answer maybe.
Yeah.
Thank you.
Thank you.
Thank you. Okay, I think the time is up. So that's the presentation and the question and answer session in this second keynote of today. Give a big applause to Professor Surya. Okay, thank you, Professor Surya. And I will give a closing statement. No? No, okay. Okay, I will give the mic to MC now. Thank you very much.
All right, that's from Professor Surya, everybody. Let's give another big applause. All right, for the next session, we will have an appreciation session for Prof. Surya. Maybe for the committee, and Pak Norma may go up to the stage and present the appreciation plaque.
Terima kasih. Terima kasih Pak Surya atas kesediaannya untuk
Okay, maybe that is for our last keynote session for the day by Prof. Surya. And maybe for Prof. Surya, would you like to go back to your seat or would you like to? Oh, you want to pack up? Okay, okay, that's right. Okay, maybe that's our last keynote session for today, and we will move on to our next session.
Yes, as we did on the first day, we will go to the parallel session. And for those of you who is joining us online, you can go to the designated breakout rooms. And for audience who present here offline, you can go to your room, which is the parallel room 1 is besides this main hall. The parallel room 1 is on the left side and the parallel room 2 is on the right side. And for the room 3 until 5 is on the Novotel buildings across this tower. So maybe for those of you who want to go to the room 3 until 5, you can gather in front of the main hall doors because there will be a committee who will lead you there. Okay, maybe you can go there now. Yeah, maybe you can please go there now. And